So next, let's try to study about what is the color. So you may ask, what is the relation of the color to the light? So in physics, the way how we define the color is that it is the different frequency of the light, especially for the visible light. Because when you say the color, which means your eyes can see that, yeah? So only the visible light is the case. So we know that from the previous lectures, the visible light, the spectrum of that range from the 400 nanometers to the 700 nanometers. And we claim that at the 400 nanometer, the light you're going to see is a violet one, and the 700 nanometer is the red one. So the color is now related to the concept of wavelengths. So which means that the longer the wavelengths, the color will be closer to the red or yellow. The shorter of the wavelengths, the color will go to the blue light or the violet light. So in physics, now you can try to connect the concept of color is either decided by the wavelengths or the frequency of the visible light. And here is the range. We know that for the visible light, it is composed of the red, orange, yellow, green, blue, indigo, and violet. So the visible light is composed of all of them. Okay, so this is a very crucial concept. The light is composed of different kind of frequency of the EM wave, and each unique frequency of the EM wave have their own unique color. And this is how we define the color in physics. So now let's try to start in one thing. So what is the color you see? Do you have this kind of experience when you try to go to the shopping mall and buy the clothes? When you give it a try, you will think the color is more like the black. But when you go out, you will find the color of the clothes is more close to the dark navy. The same here. When you try to have your lips with the color, so originally you thought it looks more like the pink. But when you go outdoors, you will find out the color of your lips now become more fresh red. So what is the explanation for that? So I already defined what is the meaning of a color in physics. Now I'm going to provide you the second important thing, is that the color also depends on the source, the light source. So what I mean is that there are two different kinds of source. In the natures, one of the sources is that like the sun that produces light. The second kind of light source is that the leaves, like for example, they don't event itself produce the light, but they will reflect the light. Okay, so no matter in what kind of scenario, they can all play as a source of the light, and the color actually depend on that. So you must feel a little bit confused what I'm trying to say. So let me give you an example. So let me define the so-called concept of the selective reflections. Now you will have better sense of feeling why we have to study the law of the reflections. So now the light is composed of a different kind of frequency of the EM wave. So the reflections will be different for different color of the light. So what will happen is that, for example, the skin of the tomato looks red. What happens is that there is a light from the sun, which is a white light. So later on, I will define that actually the white light is composed of the green, red, and the blue. So they will hit on the surface of tomatoes, but you will find out only the red light can be reflected. All other frequency of the light within the white light from the sun, they are all absorbed. So that is the reason why the skin of the tomato looks red to you, because the red color of the light is the only one reach your eyes. So here it is a typical examples. So this one actually justify what I just said, is that the color depend on the source. So when you look at this kind of triangles, you thought it is white. It is because all the colors are reflected. But if you try to coat it with a different kind of paintings, you'll find out all the light was absorbed and no one will be reflected, so it looks dark. Then you put another different kind of coating, then only the red color is reflected. So they are all the same object with different kind of coatings, but the color looks different. It depends on which light is reflected. Even those itself do not emit the light, but they can reflect the light, so they still can place the rule of the light source, and the color depends on that. So this is a very important concept, and this kind of phenomena is the so-called selective reflections. What kind of light is reflected? But now I have to go back to explain to you what do I mean by the white light. You can consider the white light is nothing but just the visible light. And people study that the visible light is composed of the three colors, red, green, and blue. If you combine the red, green, and blue light together, you will produce the white light. If you combine the red and blue, you will create a magenta, the color. If you combine the red light and the green, you will create a yellow light. Okay, so they are the so-called primary one to make the white lights. The red, green, blue make the white light. But you can see that there is a secondary color. So you will find out the secondary color is yellow, the cyan, and magenta. If you combine the yellow and magenta, you will produce the red one. But people will have a shock and a surprise is that if you combine the yellow, magenta, and cyan together, it will become dark, brown or black instead of the white. Why it is the case? So before I provide you the explanation, please remember this is the primary one, this is the secondary color. So the reason is why when you mix different kind of paint color produce a brown instead of white. Did you see that? Now I give you a keyword, paint color. So you can consider this is the one you can use when you try to provide different kind of coating on the surface. But this is the one for the light only. Did you see the difference now? So this is the light and this is the coating on the interaction surface. So this one actually determines what kind of light will be reflected. But this is the light itself. So in the future, when you provide these two different kind of diagrams, you should know that this applies to the light only and this applies to the painting or the coating itself. So this is a very intrinsic difference. When I was a kid, I do not really understand why they provide me two things since they contradict to each other. So in the future, no matter it is a quiz or the exam, you should make sure it is for the light or for the pens. Okay, I will give you more explanations. So before I give you the second conceptual quiz, I just want to remind you that is. So this kind of deflective refraction is that the white light is made of the different kind of frequency of the light. So do you remember when I introduced you the concept of refractions? Each of the light will have different kind of angle of the refractions. So therefore, when they're passing through the prisms, if you have the red color, the index of refraction is different from the index of refraction for the violet. So therefore, after they leave the prisms, all the different kind of frequency of the color will be separate. So that's the reason we know that the white color is actually made of the yellow, the green, red, and the blue. Okay. So now let me have the second conceptual quiz, and this will be the one I'm not going to provide you the answer today. So please think about that. Which one is the answers? Then if you think you know what is the answer, please email me your answers with the explanation using the lectures based on the information and knowledge you learned in the lecture today. Okay. So now, without answering that, I'm going to use the so-called selective reflection to let you understand why the colors, when you combine different kind of paint color together, they will produce a brown. It is because when you have the red coatings, only the red light can be reflected. When you have the green coatings, only the green light will be reflected. But when you have the coatings which combine red, green, blue, then none of the light can be reflected. So in that case, all the light will be absorbed. So therefore, when you combine different kind of pen color, they only give you a dark color because all the green, blue, red color light was absorbed. So here is a very good example to help you to understand. When you take the photos and you try to print them out, actually, depending on what kind of pen color you choose, you can determine different kind of color of the photo. So here, this is the one we just have for the pen color. So the first one, you only use the magenta one to print the photos. And you can see magenta is the only color, so it looks pink, yeah. The second one, you only use the yellow color, yellow pen or ink. So apparently, the photo looks like that. And third one, you use a cyan. And now the fourth one is the one you use the yellow and the cyan combined together. And also the magenta. So they are more close to the realistic, yeah. But still, it is not perfect. So don't forget about that. If you combine these three, you will have the black ones. So if you try to print the photo just in terms of the black colors, you are going to have the number E here. So the final case is the one show the true color of the photo is simply combine the magenta, yellow, cyan, and the black together, you will produce these photos. So actually, these slides show you that the color on the photo actually is determined by what kind of pen or the ink you choose. Okay, so intrinsically, no one can tell you that which one is more realistic and which one is less realistic. But you will say this one is close to realistic is because this is close to the image we see through our eyes. Agree? So this is a very crucial fact. But the image you see through your eyes is through the light combination. But here it is through the pen or ink combination.